All right, we're on our additional focus area on gravity. We're going to combine objectives 2 and 3 as they're really similar and both pretty short. So, quick review of the main stuff that we learned in objective 1. We said gravity. It's an attractive force, meaning it pulls together every object in the universe. The closer the objects are, and the more mass that the objects have, the stronger the gravity will be. So, closeness and mass determine the strength of gravity. Mass does not change. It's the amount of matter or stuff in an object. So wherever you are in the universe, your mass would be the same. However, weight is a measurement of how gravity affects mass. So if you look at this little picture over here, it says if you weigh 100 pounds on Earth, you'd only be 17 pounds on the moon, 38 pounds on Mercury, but you'd weigh 253 on Jupiter. What that tells us is the planets or places like the moon that you weigh less means those planets or the moon have less mass, thus less gravity. Jupiter, since you'd weigh more there, has more mass and thus stronger gravity. Gravity is a non-contact force. Remember from the fifth focus area, that means it acts when objects aren't touching. And it's also called an action at a distance force. Same reason, because it can act on objects that are not touching. All right, so let's move on to a new topic called free fall. When you hear somebody say an object is free falling, it means that the object is falling and the only thing that's affecting it is gravity. There's two really important characteristics that are true of all free falling objects. One, they don't encounter air resistance, so no air resistance. And all free falling objects fall at the same rate. The rate's 9.8 meters per second squared. It's called acceleration due to gravity, but all objects that are in free fall at the exact same speed. So if they're dropped from the same height, they would land at the same time. And that's what this is saying. So they're saying, look here, we have a 1,000-kilogram baby elephant and a 1-kilogram little mouse. If they were to drop from the same height at the same time, they'd actually land at the same time. They'd hit the ground at the exact same time, which you might not think should be true. You might think, well, the elephant's bigger, so it's going to fall faster. But here's why. Newton's second law. Remember, force equals mass times acceleration. If we actually apply that to the mouse and the elephant that are falling, and we know they're in free fall, yes, the mass of the elephant is greater, so you would say it's going to have a greater force of gravity, which is true. However, it's harder to accelerate or make something move that's really heavy. When we do the math and solve for acceleration, which means we have to divide both sides by mass, so the force divided by mass, what we end up getting is, if you see the math up here, for the elephant, the force of gravity is 10,000 newtons. He weighs 1,000 kilograms. We do the math, it's 10 meters per second squared. Now, the force of gravity acting on the mouse is smaller. It's only 10. But look, so is his mass. And when we divide 10 by 1, we also get 10 meters per second squared. In other words, they fall at the same rate and they would land at the same time. Another similar example, if you were to drop a bowling ball and a basketball at the same time from the same distance, a lot of students would say, well, the bowling ball is heavier, it will land first. That's not true. Remember, when we're talking free fall, only gravity is affecting it. All objects fall at the same time, same speed, and land at the same time. So the bowling ball has greater mass, gravity's pulling on it faster, but it's harder to accelerate because it's heavier. It's easier to accelerate the lighter basketball. And when we do the math, guess what? They also fall at that 9.8 meters per second square that we often round up to 10. Now, if air resistance counts, if something's falling and air resistance affecting it, then it will be slowed down. So if we drop feathers and a brick According to, if they were in free fall, yes, they would land at the same time. But we know that surface area of the feathers and how light they are would cause air resistance to slow it down. So remember, free fall is only when gravity is affecting it. If air resistance plays, then all bets are off. But for the sake of this focus area, we're always going to assume that things are in free fall. So whatever objects are dropped, they will land at the same time. Yet another example, large rock, small pebble. They fall near the surface of Earth. Guess what? They're going to land at the same time and accelerate at the same rate. Here's a question that might actually be on your test. Student drops a bowling ball and an apple from a third-story window. Both objects hit the ground at the same time. The reason is gravity pulls on them both, and it causes them both to fall at the exact same speed or same rate. So summary of our new stuff. Free fall, new definition. Falling objects only being affected by gravity. Any object in free fall falls at the same speed or rate, which is 9.8 meters per second squared, but just know they'll land at the same time. So two objects, no matter how much they weigh, if they're dropped at the same time from the same height, they will land at the same time.